Hi, welcome to Moose and Chemistry, SI Unit Scientific Notation Lesson 1. So what we're going to do today, thank you Tom, we're going to look at how to write numbers in scientific notation. Let's start off with a few. Let's say, for example, you had 10 to the second. What does that really mean? What that really means is this is equal to 100. If we wanted to put that in scientific notation, we would want to move this 2 places over. So this would actually be 1.0 times 10 to the second power. Let's look at another one. What if it were, say, 10 to the 0? All right? 10 to the 0 is 1. So in essence, what you would do, you would write 1 times 10 to the 0 power. What if you had a negative number, like, say, -3? All right, so what you're going to do is you're going to write 1.0 to start with. You see that -3, you're going to move it 1, 2, 3 spaces and put a decimal. So in essence, what that really means is you're going to have 0.001. You could drop the 0 on the end if you want to. Let's take another example. What if you had it set up like this? 6 times 10 to the -3. Well, we would write 6 and then we go 1, 2, 3. And you put the decimal. In those empty cups, you would put in zeros. So the answer is going to be 0.006. Okay, what if you had something like, say, 800 times 10 to the -2? Well, you write down the number 800, and then you're going to move it 1, 2 spaces. So your answer is going to be 8.00 if you want to be technical about it. And what if you had something set up like this? 2.4 times 10 to the third. Well, you would write down 2.4, move it 3 spaces, 1, 2, 3. Remember, if it's a positive number, so it's going to, first of all, it's going to give me 2,400. Whoops, too many zeros. So remember, if it's a positive number, you move the decimal this way. If it's a negative number, you would move the decimal that way. Okay, when you're looking at the numbers. Okay, dokie. So now, let's look at a couple of more problems here. First of all, let's clear all these drawings off. And we'll clear all the drawings there, clear them. Okay, and now let's look at, say, multiplying with scientific notation. So when we multiply with scientific notation, let's say, for example, we have 3 times 10 to the third times 4 times 10 to the second. What you're going to do is you're going to multiply these two numbers. Okay, so that would give us 12. Then you're going to take these two numbers and you're going to add them. So this gives me 12 times 10 to the fifth. However, this is not quite right. So we want to make sure that we want to move it this direction. So it's 1.0 times 10 to the 6. All right. And this would give me, of course, if it were set up like this, then we go 1, 2, 3, 4, 5. So you put zeros in there. And that would give me basically 1,200,000. And then if we do this, we go 1, 2, 3, 4, 5, 6. And as you can tell, the number is exactly the same. All we did was we put a decimal between the two numbers. And in correct scientific notation, you have to have at least one number to the left of the decimal. Okay, so this it seems pretty easy so far. All right, let's do a couple of quick problems with this. So let's clear these drawings out and let's do some multiplication. Okay, so we're going to let's try 1 times 10 to the third times 5 times 10 to the first. Again, remember, multiply these two. So it gives me 5. And then remember, you're going to add these. You're going to add those. And you're going to multiply these. Okay? So this gives me 10 to the fourth. Okay, which is also the same thing as 5.0 times 10 to the fourth. And if you want the decimal number for this, this would be 5.0. You go 1, 2, 3, 4. Place in the zeros, which would mean that this is 50,000. Let's look at another one like this. All right, let's say 5 times 10 to the negative fifth times 11 times 10 to the fourth. Well, the first thing you want to do is you want to take this 11 and you're going to change it to, this is going to become 5 times 10 to the negative fifth times 1.1 times 10 to the fifth. Okay, so what we're going to do is, remember, we're going to multiply these two guys right here. Okay, and you're going to add these guys right here. So this is going to give me 5.5 times 10 to the 0, which is 5.5. All right, let's clear these drawings real quickly. And what if we were going to divide scientific notation? So let's take this in case in point. 12 times 10 to the third divided by 4 times 10 to the second. Let's make that 4 a little bit better. I don't like that 4 there. And let's go. So we're going to divide 12 by 4 times 10, 3 minus 2. So when you bring this 2 up, it's going to become a negative 2. And you're going to subtract it. So this is going to give me 3.0 times 10 to the first, which is 3.0. Okay, let's look at another one like this. Let's say this problem, for example. We have 4 times 10 to the third divided by 8 times 10 to the fifth. Okay, so we're going to put 4 over 8 times 10, 3 minus 5. This is going to give me 0.5 times 10 to the negative 2. So now that we have that, but look, we don't have any number to the left of the decimal. So we're going to want to move this decimal this direction here. This is going to be 0.50 times 10 to the negative third. So if we were going to write this in decimal form, it would be 0.005, because you would go 5.0, you go 1, 2, 3, and you're going to want to put zeros in that empty cup. Okay, that's two division problems. Let's look at adding scientific notation next, okay? So we're going to add scientific notation next. So let's go ahead and clear these drawings out. Clear all this right here. And now we're going to add scientific notations. Let's take this problem. 4 times 10 to the third plus 3 times 10 to the second. Okay, now when we look at that, we want these numbers, these exponents here, to be the same. When you add, you're going to bring this one up higher. You're going to make this one higher. So this becomes 4 times 10 to the third plus 0.3 times 10 to the third. And then when you add these two together, you're going to add these guys, which give me 4.3, and these guys will remain as 10 to the third. And there you go. So let us look at the next one. Okay. So let's look at one more on this one here. Let's say this problem. We have 9 times 10 to the second plus 1 times 10 to the fourth. Okay, so we're going to want to make this one higher. Okay? Remember, this one's got to go higher. So this is going to give me, it's going to become, let's see here. Oh yes, we're going to move it over 2 spaces. 109 times 10 to the, hang on for a moment. Let me back this up for 1 second, guys, no problem. So, let's see here. We got a 4 here. We want to make this a 2. So 2's got to go higher. So to do that, we're going to want to go this direction twice. 1, 2. Gives me 0.09. So you got 0.09 plus 1 times 10 to the fourth, which is going to give me 1.09 times 10 to the fourth, which is the same thing as, you go move it 1, 2, 3, 4, put zeros in there, and of course this would be 10,900. Okay, so let's go and do one more lesson here, clear all our drawings out, and we're going to clear that out again. We need to erase that, whatever that stray mark is, and this time we're going to subtract. When we subtract, let's take this problem for example. 3 times 10 to the fourth minus 2 times 10 to the third. Okay, so what we want to do is we want to take this larger number and make it smaller. Doing that, we're going to make this 30 times 10 to the third minus 2 times 10 to the third. Now these 3's are all the same, so this will equal 28 times 10 to the third. But remember, we need a decimal between these two numbers. So we're going to make this 2.8 times 10 to the fourth. Okay, let's look at one more in that area, and then we'll be done. All right, let's say, for example, let's do a double negative. Let's get really cool here. 3 times 10 to the negative 6 minus 5 times 10 to the negative 7. Well, remember that the negative 6, okay, it's going to become a negative 7. All right, so let's take a moment here. And we look at this and we go, oh, this number is actually, it looks bigger. So we got to make this a negative 6. So this one becomes 3 times 10 to the negative 6 minus 0.5 times 10 to the negative 6. Now they're all the same. So then what we're going to do is we're going to subtract the 2. This is going to give me 2.5 times 10 to the negative 6, which is the same thing as you go 2.5, go 1, 2, 3, 4, 5, 6. Put our zeros in there, and that looks good. And so our answer in our decimal form is going to be 0.0000025. And with that, you know, you might feel like you're kind of doing some cool stuff like this.
She's a good girl.
So we're kind of free falling, like Tom Petty's saying. And so
crazy.
And you guys have an awesome day, and we look forward to seeing you again at Moose and Chemistry.
She's a good
All right.